Let's pack our bags and take a quick trip to Asia. We'll check on 5 of the most interesting robotics projects going on there. Let's stop in East Asia for an update on some of China's most promising projects in maritime robotics. Then we'll slip across the Sea of Japan to a Japanese project that's teaching robots how to build a massive dam. Then we'll head south to Southeast Asia and the 10 ASEAN nations there, stopping at one, Singapore, to witness an interesting reboot of industrial cleaning robots, robot teams cleaning together. With the permission of the United Nations International Seabed Authority, China has been mineral hunting in the world's oceans for the past decade. Chinese researchers now say that they have identified a number of important deep-sea mineral deposits, including nickel and rare earths. Why is that important? First off, China is the world's biggest consumer of minerals, but its domestic ore supply falls far short of the massive demand. Secondly, the ore grade of seabed mining is extremely high, 99%, as opposed to geological ore supplies, 2 to 20%. One of the biggest seabed mining areas is the Clarion-Clipperton Zone, which is the size of Europe. In that zone, there's a total mass of manganese nodules there, over 21 billion tons worth. Into this deep-sea mining world will go Kunlun 500, which looks like a massive bulldozer. Still in experimental phase, the operator-controlled or autonomously operated Kunlun 500 can work at a maximum depth of 6,000 meters, almost 20,000 feet. In 1 hour, the machine can locate, break apart, and gather 10 tons of ore that would then be sucked into a surface ship through a pipeline. I had similar hopes for this kind of deep-sea mining from a company in Canada called Nautilus Minerals. However, it went bankrupt in 2019. So the Kunlun 500 is the only game in town right now. Deep-sea monitoring. For persistent observations of deep-sea mining, Chinese maritime technology has come up with the RoboSnail, based on the soft-bodied deep-sea snailfish discovered in 2014 living 26,000 feet down in the Mariana Trench. Down there, the pressure is 15,000 pounds per square inch, as opposed to the surface, where it's 1 atmosphere at 14.7 pounds per square inch. Researchers compare the pressure of an elephant standing on your thumb when you're down that deep. The squishy, translucent fish that lives as much as nearly 5 miles deep in the Mariana Trench now has a robot cousin, RoboFish, which pushes the boundaries of biologically inspired soft robots. Its skull is not completely fused together with hardened bone. That extra bit of malleability allows the pressure on the skull to equalize. In a similar vein, the scientists decided to distribute the electronics, the brain, of their robot fish further apart than they normally would, and then encase them in soft silicon to keep them from touching. That protects the electronics needed not only to power propulsion and navigation, but also to perform various tasks like observing deep-sea mining or sample collection. Back on the surface, China's maritime robotics offers up an unmanned scientific research ship that will carry drones and be able to conduct air, sea surface, and underwater monitoring remotely and navigate autonomously in open water. At 300 feet by 45 feet and a displacement of 2,100 tons, the robot craft will provide maintenance to offshore wind farms, seabed mapping, and environmental monitoring, reports China State Shipbuilding Corporation. With Japan experiencing a severe shortage of construction workers, and with 35% of those on the job over 55 years old and facing retirement, Obayashi Construction Company is turning to robots to build a massive dam. At 275 feet high and over 1,000 feet long, the dam, when complete in 2023, will be the largest structure ever built by robots. Every process for constructing the hulking dam will involve some form of automation, including initial work building the foundation and pouring concrete to form the body. By transferring expert techniques to machines, we're able to analyze what was once implicit knowledge, said Akira Naito, head of Obayashi's Dam Technology Unit. Companies are scrambling to build robots based on workers' expertise before they retire, reports the Nikkei Asian Review. The companies also hope that the new technology could dispel negative stereotypes of industry among younger generations, encouraging more people to work in construction. Singapore, first ever cleaning robots that work as a team. Professor Mohan Rajasalara, a robotics AI expert from Singapore University, together with Singaporean entrepreneurs Dylan Ng and Michelle So, the husband and wife team behind Singapore's leading cleaning equipment and chemical supplier, Supersteam Asia Pacific, co-founded LionsBot in 2018, and now have launched the LeoBots line of commercial cleaning robots. Today, just 3 short years later, the LeoBot line has grown to 5: Leo Scrub, Leo Vac, Leo Mop, Leo Pull, and Leo Ray for COVID ultraviolet irradiation. Unlike other automated cleaning products, LionsBot robots operate either as standalone units or alternatively in fully coordinated, fully autonomous teams for enhanced productivity and improved cleaning results. This is a first. Entire robo teams can be deployed to designated spaces to clean in unison and with minimum human intervention. To optimize cleaning plans, LionsBot robots collaborate with each other using AI and big data analytics. If you're interested in more of these one-of-a-kind robotics innovations from Asia, click on over to Asian Robotics Review and let serendipity run wild at our article index. You'll stumble upon hundreds more gems like these. Asian Robotics Review, where curiosity is never disappointed.